Hi guys, welcome to Siemon here with SDVoE. We're really just talking about not being afraid of running a data network, running AV signals over an IP network. So when we start looking at this and we start looking at the tradition of how we were doing it, we saw something called HDBaset come on. Now HDBaset is not really a true Ethernet based application. It was something that sits in the middle, doesn't really fall in line with what we would call traditional data networking. The whole idea of this is you could run 100 watts of power and try and get up to 100 meters of data transmission. But we're now moving towards HDBaset IP, and this is using more traditionally standards-based AV systems running over more traditional IP applications. So lots of stuff is still in development in terms of SDVoE, but if you think about it from a networking point, Category 5E, Category 6, Category 6A, Category 7 cables, fiber cables, they've been out there working very successfully for years. So it absolutely makes sense that we're going to start bringing the AV technology onto a traditional networking platform. So we use typically here in AVoIP, we're going to use Ethernet IP switches. We're not going to use those traditional matrix switches. We are able to do a little bit of compression and uncompressed data as we're being able to move it across. And this is as we start moving towards higher. But with SDVoE, we're talking about real high definition systems and how we can drive that forward over a copper-based and fiber-based network. So if we start looking at the different types of technology out there, you know, video, when we start looking at it, it's got to be compressed if we're running an HDBaset. If we start looking at SDVoE, we're using the term uncompressed, but I think there is a marginal amount of compression. I have seen today some sort of solutions that are talking about running over IP-based, Ethernet-based connections, where they're talking about marginal connections, and they're talking about data streams up to around about 18 gigabit. So that's not within that HDBaset world. If we start moving into Ethernet, that's where we really start driving it forward. If we look now at most infrastructures that are going into buildings, nobody's installing Category 5E, nobody's installing Category 6 buildings, everybody's installing Category 6A for all of their data networking. The whole point of an AV system is we can add it onto that system as it's being installed. And if you think about it, if you're investing all of that money into a building now that's going to support a customer for 10 to 15 years, we don't want to rip out any cabling plant that we've already installed. So we need the higher data rates looking at where the future is going to be. If we start looking at up here, 100 watts with HDBaset, but if we start looking in the terms of power over Ethernet, we're now up to 90 watts and we're delivering 100 meters. Now, one of the big issues when I start talking about the difference between HDBaset is if you look at HDBaset, one of the issues is, can you drive that signal 100 meters, high definition, on something like Category 5 or Category 6? And the answer is you can't. You're looking at 50, 60 meter reductions. If I'm designing a building, I don't want to touch that infrastructure for 10, 15, 20 years. I might want to move my screens, my AV systems. If I've built the infrastructure right, we will be able to support it moving forward. So cabling standards. Well, a bit like HDBaset has really got its own standard, but if we start looking at the networking world and we start thinking about voice and data and any other type of application that we're now able to deliver over a cabling system, we're actually governed by technical standards. So in Europe we have EN 50174. It's a generic cabling standard that every cable installer fully understands. We've also then got our local country codes, and then we've got our international codes. So these actually tell us how we're going to design, how we're going to deliver that cabling plant, which is going to be able to support that AV system. So standards. So typically for a standard for us, if we're running say 10G-Baset, we're running that up to 90 meters on what we call a horizontal link. We call it a permanent link, and then if we want to extend it, we give ourselves an extra 10 meters for patch cords at the end. And that's a really important thing about patch cords, because we're going to be able to, without having really ultra specialist equipment now in terms of AV cables, we're going to be using a Category 6A or a Category 7 cable, and we'll be plugging it straight into the end device. Typically no more than 4 connectors in a channel. Yeah, now typically standards don't talk about point-to-point connections, and this is actually not in terms of performance, it's actually talking about flexibility within your system. What we're trying to do is create as much flexibility for thinking about moves, adds and change. So typically when, say, someone are going to install an AV system, they would do a direct attach link and that link stays there. If that customer wants to move it or change it, they've got to go in and bring in new cabling plant. What we're able to do is have flexibility where we can patch and move. If we can patch and move on a traditional AV system, on a traditional IP-based data system, that's going to give it much better for all of us. So we're going to look at things like 2-plug connections and everything else, and we'll talk about those in a bit later. But this is really how we're going to make it look. So what we've done is, in the old days, you used to be able to terminate an RJ45 connector, and that really sort of ended with the end of Category 5E. When Category 6 came onto the market, you couldn't terminate a Category 6 cable onto an RJ45. So what we've done as Siemon is we've actually developed now a new style, a fast style of connector, similar to an RJ45, that would take a fully shielded cable from Category 6A, Category 7, Category 7A, and be able to terminate it in around about a minute, so we can then have a direct attachment directly into the equipment that we're working with. Now this is going to make our life a lot easier, because it's going to mean faster termination than the way in which we work. Now there's another thing. How many of you guys who are installing traditional AV cable are using something like coaxial? Anybody still using coaxial? No? Anybody using any other type of cable? But do you know if that cable is CPR compliant? Has anybody heard of CPR compliance? No? So CPR compliance is all about fire safety rating of buildings, and that your cables have to meet a certain fire class. So every cable now that's manufactured that goes into a building in Europe needs to meet a specific class. Typically these classes will be either a Class B cable, or Class C cable, or a Class D. Nothing to do with performance in terms of data throughput. It is a legal requirement that these cables are being installed into buildings do meet the fire classes. If anybody wants to talk to me about that after, more than happy to speak about it. But what have we got here? We've got a nice little simple picture. We've got a fibre directing back to our LAN environment, our local area network. We've got our AV or Ethernet switch, and then we are literally running a cable directly out to that end device. We're putting on a field termination plug, a modular termination field plug, and then we're connecting directly into that device. We're not having to worry about outlets, we're not having to worry about long patch cords. Now one of the biggest issues with patch cords, if anybody works with a patch cord, it is typically a stranded cord. It is not a solid cord cable. If we are trying to deliver high definition video over distances of like 90 and 100 meters, stranded cord will attenuate signal more. There is more chance for crosstalk and more delay skew on the cable, which will affect the video transmissions that you're trying to look at. So for us, a 3-connector model, 3 connections coming from the LAN, going to a patch panel out to another area, and then from that area we're then going to connect into the device, will give us as much flexibility as we absolutely need. It means we can design once. Whatever that building needs to be, we can design it once, and we can give our customer exactly what they need moving forward into the future, especially in terms of that AV. It's going to make for things like much easier moves, adds and changes, and it's going to save your customers and our customers a huge amount of money. So, big thing about here is shielded cables. Big driver in the whole of Europe now, everybody's looking for shielded cables, and there's various types of shielded cables on the market that exist. We have cables like FUTP, foil unshielded twisted pair, we have unshielded foil twisted pair, we have foil twisted pair, and we've got SFTP, which is a Category 7 cable, which is a shielded foil twisted pair. Now all of these cables are designed there because what we want to try and do with the different design characteristics of these cables is to stop interference coming onto the cable, and these cables working at high frequency affecting any other cable. So when we start talking about 10 gigabit, we are talking about a huge amount of transmission signal, high amounts of transmission frequency that we cannot afford to let that be corrupted, and we cannot let that cable affect anything else in its environment. So most customers are now literally moving towards shielded cables because these offer the best protection in terms of immunity. You can buy category 5E, you can buy category 6 cables, but typically if you look at most of the business markets today, and even if you look at companies like Crestron, even those guys are now talking about using fully shielded cables such as SFDP, because it's about noise immunity and how we move forward. So the last thing there that we're looking at, especially for the AV market, is either category 6A, FUTP, FFTP, or category 7, which I call the Arnold Schwarzenegger of the cabling world, because that is the most robust cabling system that's available on the market. So why would we use category 6A? Well, there's lots of reasons here. I don't want to go into, happy to talk with anyone offline if they really want to get into it, but there's low latency, high data transfer, high speed, little delay skew. Over all of those 4 pairs, we're splitting up the data transmission, we're delivering it, and that's going to reach the end exactly as we've sent it up. Easier to test for higher speed networks, because the installers that install this type of cable, they've got actually test equipment which will guarantee that data through performance. So if we know that's going to work, if we've ever got to go into a fault finding situation, all we've got to do is just test the cable, and then we know it's not the cable, it's more the active equipment. And I find it strange how sometimes when I talk to the AV guys that I say, how do you know it's good? And they go, well, we're not really sure. And they start on the active equipment rather than looking at the cabling plant. Well, the cabling plant is by far the quickest and the easiest point to check. Get that checked to make sure it's going to work. And whatever we want to do, I keep going back to this about designing that building, but the more that we can make that building more fluid, the more that we can add things to it in terms of application intelligence, is going to make it far easier for the customer. Now, when we're literally talking about a cable, and we are literally talking cables that are running in high speed, a 10G network, it's enormous amounts of data, and that enormous amount of data really wants to radiate from that cable. So we start talking about things now like called alien next, alien crosstalk, and what we're trying to do is to make sure that that signal integrity is maintained within that cable pair, that it cannot affect anything else. There's going to be no internal crosstalk affecting those cables. Another little thing, when we start talking about technology now, we start talking about things like power over Ethernet. How are we going to get the power to these devices? And power over Ethernet, if you think about it, if we're delivering 90 watts over a cable, what's going to happen to that cable? Is that cable going to heat up? Well, the reality is if a cable can overheat, it will affect the amount of that data transmission. So we've done a lot of work literally there trying to maximize the protection within the cable, so we're going to deal with it. But here we go. So if we start thinking about things like, I don't know, a category 6 cable, and we start looking at a category 6 cable, and I'm looking at the environment in which I'm about to install it, I'm thinking about the heat levels that I'm going to put over it, I've actually got to start derating that length of the cable, which actually means that if I say, for example, I was working with an HDBaset, working on something like category 5E, I know that I've got to reduce that down to 50 meters anyway, but if I start over egging the heat build up on that cable, I've got to reduce the length of that cable even further. So it's all about trying to get with a system that's going to be most robust, that's going to be available on the market, and can deal with these heat dissipation that we're going to deal with. So what we're trying to do is we're trying to, with a shielded cable, dissipate heat much better, much more controlled, to 100% guarantee that signal performance. Another little thing that we need to talk about, nobody ever thinks about it, as we start moving into the world of PoE, we are delivering power that's going to go down that cable, that power is going to go down that cable, and that power may be going into your AV device. So the AV device says, yes, I need power. The power is then sent down that cable, and it's delivering that 90 watts. What we've actually realized is that when you actually need to remove it, we're not turning the power off. So if you're then removing it, what is their potential for? there's going to be a potential for damage because you've got something under load, and if you're going to remove it with an RJ45, you really give yourself a potential issue. So just to show you, just coming up here, this is a connector. It's just a blade that you plug into any device, and that's one of those 8 pins on an RJ45 that you plug in. Absolutely no damage. It's newly there, nothing been done to it. This is a conductor that's literally working with now power over Ethernet, and we got those two connections working together. And then if I start literally unplugging those RJ45s, what do we risk? We run the risk of an electrical arc. And that electrical arc will start to damage the quality of your connections. So a lot of work's been done within the European standards. Our company, Siemon, has been really driving this forward, that we've actually changed the design of our RJ45 so there is no real contact point. The disconnection point actually occurs, so if there is going to be any damage, that disconnection point occurs far away from the mated position, which means that we have a much greater life cycle out of the connectivity, and also the less potential of doing damage when you're using power over Ethernet. Sorry, I'll go back. Can you see that last one? Look at the damage. Yeah, power over Ethernet, no interest to it, just being pulled out. So we've got to think about how we're going to do it. So I'm going to talk about industry standards. Now, if I start talking to a customer today and I start looking at tender documents, and I read a lot of tender documents, one of the most interesting things is we talk to a customer and our customer says, I want the longest lasting cabling solution that I can have on the market. And they quite often will quote a standard. Now, whether they're quoting an international standard or a European standard, all of those standards are now saying for buildings and infrastructure we're going to be putting, yeah, that we must use category 6A as a minimum. Remember, we're trying to devise a roadway that's going to be a minimum of 10 gigabit to be able to deliver to that customer whatever they need today and for tomorrow. So even if you've got a customer that could be installing a category 5E or category 6 solution, they've got a major problem because it will not support future applications. I mean, how many of you guys here own a laptop? I guess everybody owns a laptop. How often does that laptop need to be upgraded? Because the technology is moving on. Data speeds are moving on. We're seeing switches now where the switches, people are moving towards 10 gigabit switches because the amount of data, 4K data, the amount of high definition data is taking up more and more bandwidth. So whether you're in Europe, you're in the international world, or you're in the North American world, all of the global standards are actually saying if you're going to be doing this, you've got to also not only be using a category 6A cable as a minimum, they're also saying because of the high frequency, you've got to be using shielded cable. Lots of manufacturers out there still saying use UTP, not at high frequencies. Please don't do it. If any of you guys are really interested in learning more about the technical standards of infrastructure for cabling, please by all means go and have a look at our blog there. We call it the Standard Informant. It's HDBaset Siemon. It's our blog that you can go on there. So final points. Category 6A cabling or better will support all AV application deployments over twisted pairs to 100 meters. If you need to think about moving beyond that, we can obviously move to fiber solutions. Very fast field termination fiber. You don't need to go out and buy fusion splices. We've got mechanical devices so you can deal with that as well, which I'm happy to show. Industry standards, yeah. Point-to-point connections are not standards compliant. Remember that. Doesn't work for our buildings, doesn't give us flexibility as well. But having field termination plugs, yeah, is now going to make our lives easier. Now I've got some over here if anybody wants to see them, but they're very, very quick to terminate. They are not specialist plugs. These are standard industry connectors that exist in our world. And zone cabling. So the whole idea about when I'm designing today, I'm talking about flexibility. So instead of running just out one cable from one device to from a patch panel to an application, I'm trying to bring everything into a zone or a cluster. I'm then bringing all the cabling there, and then I'm using solid core patch cords, not stranded, solid core, and then what I'm doing is I'm connecting in devices as they need it. If we want to move the AV, all I've got to do is unplug it, take it to the next zone, and plug it into the next zone. Because it's IP, the switch will know what it's trying to do. So it's going to make all of our lives so much easier working for it. High performance cable. Yeah, I don't know what to say. If you think about it, if you're trying to build a roadway, you want that roadway to be as smooth as it possibly can, especially if you're going to be driving down it. I am sending huge amounts of data packets, 10 gig of data down this cable. So the better the cable that we've got, the better the connectivity that we've got, the better installation that we've got is going to guarantee that system for our customer. Now, one thing just quickly here. One of the issues that we have is when people install cabling plant, they only find out they've got an issue when it's too late. Yeah. So if you're trying to make something work, if you're trying to deliver it and it starts playing up, if you find out it's the cabling plant, you found out too late, because it's really expensive to go back and fix. I want you to think about it. In your offices, in your personal lives, we've all now running stuff over data cabling. Everything's sitting there. The higher rates are now being installed. Every building that I now design, everything is category 6A as a minimum. Those customers are having truly first-time data rate experiences. They're not waiting for data. They're not missing data packets. It's coming as it's needed. And it's all being driven by IP. I'll talk about that. If anybody wants to talk about art geometry, we can talk about it just over there. But the real point is that if we're talking about technology today, we're going to be moving away from those manufacturer-dependent cable, application-dependent cable. We are moving, so everything's going to be sitting on category 6A and where we need it to be. So thank you for listening to me talk for a few minutes. If anybody's got any questions or want to come up, please feel free after this. Thank you very much.